Okay, and welcome to second Tricks of Independent Learning video. This is going to be the kind of reverse of the chain rule which we learned today in terms of integration, and we're going to learn a very powerful technique. I'll just get rid of that. Oh, let's move it all down. We're going to learn a very powerful technique called integration by substitution. Okay, very, very powerful. We're going to be using this a lot. This is our principal technique in solving the integrals which we need core 3, core 4, even for the FP2 and FP3 modules. This is going to be our principal technique. Now, if we consider this integral, this is one which we can do already. The integral of 1 over x squared. There's no limits, so we're going to need a constant of integration. My first step is to write this in a slightly nicer way using powers. I'm going to write that as x to the power of minus 2 dx. Now, this integral then, we add the power, divide by the new power. So we're adding 1 to minus 2, so we get minus 1. And we divide by the new power, which is minus 1, and we can write plus c. We can write this in a slightly easier way. We don't need that minus 1 at the bottom, and x to the minus 1 is 1 over x, so this would be minus 1 over x plus c. Okay? So that's where we got up to in core 2. What we're going to look at now is more complicated integrals. We can go for really complicated eventually, but for the minute, let's examine the integral square root of, what am I going to do, 2 plus 3x with respect to x. Okay. Now, first step, well, square root, we can't multiply out any square roots. We've got a bit of fiddliness here. My first step might be to write it using powers. So 2 plus 3x to the power of a half dx. Now this is a problem. This poses a problem because we cannot multiply out the brackets when there's a half or when there is a minus 1 or minus 2. Okay? So what we're going to do, and we're going to follow this step every single time, we've got an inside function and an outside function. The inside function is this 2 plus 3x. So what I'm going to do is, I'm always going to do this. I'm going to let u is the letter we use for this, usually, equal 2 plus 3x. I'm going to make u the inside function. Okay? Make u this isn't a mathematical way a term of saying it, it's just how I think of it. I'm going to make u the inside function. Okay? So, that means that we get u to the power of a half dx. Okay? Now, u to the power of a half, we could quite easily integrate that by adding the power divided by the new power. The trouble is, this dx is telling us we need to integrate it with respect to x. And we've got a u in the integral. Now, these aren't compatible. If we want to integrate u, we need to have a du there. Okay? So what we do is, we do something quite nice, really. We differentiate this expression here. We differentiate this expression here. Okay? So, du dx, okay, well, if we differentiate 2, we get nothing. If we differentiate 3x, we get 3. Now, we're going to treat this equation like an equation, basically, and rearrange it to make du or in fact dx the subject. So if I rearrange it to make dx the subject, I get that du divided by 3 is equal to dx. Okay? Now, what we can do is, we can substitute this expression for dx. And what this becomes is u to the half du over 3. Okay. Now we're in a stage where we can do this because u, which is in the integrand, we're trying to integrate it with respect to u. We've got compatible letters there. Now this, what du over 3, that's not a problem because we can take the 3 out, the 1 over 3 out, and we can take it outside. So u to the half du. Now we can perform the integration with respect to u. So it's going to become a third. Now it's u to the half. We have to add the power. So we're going to add the power to get 3 over 2. And we have to divide by the new power. We have to divide by 3 over 2, which is exactly the equivalent to times in by 2/3. So I'm going to times this by 2/3. Okay? And plus c. Okay? Now finally I'm going to simplify these fractions. We've got 3 times a 3, which is 9, 2 on the top. So we get 2 u to the 3 over 2 over 3 plus c. Now that's all very well and good, but our question was involving x. So we need to resubstitute our expression for x back into u. So this will be 2 plus 3x to the power of 3 over 2 divided by, I've made a mistake there. Some of you may have spotted it. Let's go to the over 9. And this will be over 9 plus c. So the integral square root of 2 plus 3x dx is equal to that. Okay? Now let's go over, I'm going to go over another example because this is quite a fiddly thing. If you can master this, you're onto a winner. Okay? So let's do the integral of 1 over, what am I going to do? I'm going to do 2x minus 1 all squared dx. Now this is an integral which you wouldn't even dare trying to integrate at core 2. Not a problem now. Okay, now we know this integration by substitution, this should be cushy. First step, write it as a kind of power. So 2x minus 1 to the power of minus 2 dx. I know that I can't multiply these brackets out because I've got a minus 2 there. Okay, so what I'm going to do is I'm going to let u equal the inside function, which is 2x minus 1. Before I substitute it in, I'm going to work out what du dx is. So differentiate this and I get 2. I rearrange this to make dx the subject, so I get du over 2 is equal to dx. Then what I do is, go on fella, there we go. I'm going to substitute this expression and this expression back into the original integral, and then we should be able to solve it. It's certainly a little bit easier. Okay? So, the original integral here becomes the integral of, well, it's u to the minus 2 now, multiplied by, well, instead of dx, we're going to have this du over 2. Okay, the original integral equals that. Which means we can now, move that down, well, we're going to add the power to get u to the minus 1. Divide by the new power. Well, dividing by minus 1 is just putting a minus sign there. And we need to divide by 2, because we've got that divide by 2 there. And we're going to plus c. Okay? Finally, I'm going to resubstitute my expression for u. U was 2x minus 1. So I get minus 2x minus 1 to the power of minus 1 over 2 plus c. Now that looks a little bit nasty. I might be tempted to rewrite this in a different way because it's 2x minus 1 to the power of minus 1. We've got a minus sign at the top, so it'll be minus 1 over. We've got 2 at the bottom, 2 lots of 2x minus 1 plus c. And if I so wished, I could then write that as minus 1 over 4x minus 2 plus c. So the integral of 1 over 2x minus 1 squared dx is equal to this. Fishy, but we're going to do a really important technique. So, what I'm going to ask you to do, can you work out the integral of 1 over the square root of 4x minus 3 dx? Okay? The next lesson. Now remember the stages. Write it in a nice form. Okay? Write it in powers. Okay? 2. Let the inside bit be u. Okay, so you've got to figure out what the inside bit is. Find du dx, rearrange, or dx. Sub everything in, and integrate with respect to du. Okay, finally, write your answer in terms of x.